just like this? Okay, great. Yes, thank you. Keep coming, keep coming. All right. Great. Thank you very much. I'm from the United States. We don't have a lot of physics in the pub in the United States. So thank you for letting me be a part of it. Great. This talk started as a result of watching the movie Oppenheimer. Who've seen it? Okay, excellent, good. But my wife and I went to see Oppenheimer, not IMAX, just regular. And all of a sudden, there are people on the screen who I researched as a college student. So David Bohm is one of those. He's in the movie. This is his actor. And so this talk is really around kind of the difference between the movie Oppenheimer and this young scientist's career. And you can see part of him in that movie. The movie is based on the book American Prometheus, which is actually a very good historical account. I got started researching David Bohm as an undergraduate, and so I was interested in two things. I was an American history major, and I was interested in how science and American history fit together. And then I was also interested in sort of a history of science that was beyond just the great man or the great person. I wanted to know more about the people who worked in laboratories across the country, particularly during the Manhattan Project. And David Bohm and his colleagues were people who worked under J. Robert Oppenheimer and did a lot of the grunt work of the Manhattan Project in Berkeley. This is the Shelter Island Conference in 1947, and David Bohm was there. He was a physicist. He was born in Wilkes-Barre, Pennsylvania, in the United States in 1917. He went to graduate school at Penn State. Then he went to Caltech. Then he went to Berkeley to work with Oppenheimer. He was unable to. He became involved with the Communist Labor Union, FAECT, which is in the movie. He became involved in work around the Spanish Republic, and he was unable to be cleared to go to Los Alamos. So he spent the rest of the war at Berkeley with other scientists. And what was I going to say? After the war, he gets a job at Princeton University as an assistant professor. He's studying quantum physics. He's trying to really think through quantum mechanics and what comes next with it. That's why he's part of that Shelter Island group. By the late 1940s, his past catches up with him, and all of a sudden he's under indictment. He's under indictment for refusing to testify before the House Un-American Activities Committee. And the Cold War really shapes his career. And so in 1950, he is arrested, he's charged with a crime, and he ultimately loses his job at Princeton as a result. Well, that's right. During this time, though, he begins working on the hidden variables interpretation of quantum physics, and he gets interested in this through work with Albert Einstein, and he publishes two major articles in this field. These articles come out just about as he's leaving to go to Brazil, because he ends up leaving the country. And he really tries to grapple in these two articles, and then in future work with these three big questions of quantum mechanics, and they'll be familiar to most of you. But the issue of particle wave duality, the issue of action at a distance, determinism, the role of determinism in physics. This is my Australian version of David Bohm's theory, this is the particle, and it is surfing on this wave that David Bohm said existed, and that this wave that we couldn't detect yet would be able to tell you where ultimately that particle will end up on the beach. It's not an Australian theory, so there's no sharks in this theory. There's no jellyfish in this theory, but this was his one of his ideas. He was also very interested in this, this notion in the 1940s of action at a distance, which was Einstein famously called spooky action at a distance, where particles are interacting or affecting one another, even though by the laws of the speed of light, they really shouldn't be able to. And then this issue that both Einstein and Bohm are on the same side of about is the universe random? Is there a randomness built into quantum mechanics that they wanted to find another level of reality in which this no longer existed, that everything could be calculated, that it could be determined. So in other words, in Schrodinger, for Schrodinger's cat, for Bohm, he wanted the cat to either be alive or dead. He didn't want the cat to be in the in-between state. He probably wanted the cat to be alive, but that's just because he was a nice person. In his later years, by the 1960s, 1970s, Bohm really takes another turn and gets very interested in spirituality. And so this is a picture of him with Krishnamurti. He does several books with Krishnamurti, and then he ultimately does a bunch of work with the Dalai Lama. And so a lot of what he's remembered for in terms of his career comes out of this later career in which he wasn't doing as much physics, but he was really talking about the wholeness of the universe, the interconnectedness of different parts of the universe. So, back to the movie. The movie, I think, still is a great person of science vision. I don't think it gets beyond that. And so I think even though David Bohm and other people get to be in the movie and are part of the experience, you still come out of the movie thinking very much about Oppenheimer as opposed to students or other people. The other thing in the movie is that for J. Robert Oppenheimer, the whole consequence of the Cold War is losing his security clearance. In the case of David Bohm, he loses his job, he moves to Brazil, then he moves to Israel, then he moves to Britain. And for many of the physicists who worked with Oppenheimer, that wasn't unusual to have their career, interrupted by the Cold War and to have to go through a very long process to get back into science. Another piece that's not in the movie, but definitely is part of Bohm's story, is that his ideas about quantum physics and his ideas about hidden variables really don't get the hearing that they would have if he had not run into these political problems and if he had not ended up in exile. And so it's 20 or 30 years, it's until the 1970s that people start really looking at these again and testing them, and especially testing them experimentally. Great. And that's it. Thank you.